Hello, everyone. I wanted to explain the article I published today on my blog, 9datahub.com. This is about tapping into organizational knowledge and making them queryable with RAG and LangGraph. So the article talks about the fact that organizations do not really need new intelligence because they already invested years in subject matter expertise and experiments with products, iterations, and so on, and somehow built a knowledge base, internal knowledge base um, that is kind of buried. It's buried in documents, it's buried in Jira tickets and other things. So at the point of decision making, there is a need to access or readily access this type of information. And it's very hard to reach and access all these documents in real time, and um, or it could take a lot of time basically to dig for the specific information that we're needing in order to make certain decisions. And I go through different types of examples from the world of predictive maintenance, which is full of documents, PDFs, and Excel sheets where very basic information are kind of really buried about the conditions of the equipment, the schedule, maintenance, the alarms, the thresholding, and other things. And I go through all of this stuff in the article. Um, so it's becoming a really hard to dig for specific information and to find it in real time. So AI here, the approach that I'm describing in this article, which is called the retrieval augmented generation, is used basically to provide a technique by which we're able to store and index the data, the text data, into a vector database or a vector store, um, and be able to sort of split that knowledge into different chunks and turn these chunks into what we call embeddings or vectors, which represent some sort of semantic representation to these chunks of data and store them in the vector store. And this is done offline. And at real time, we're able to ask questions, and based on these questions, we're able to make a retrieval from the index store or from the vector database based on similarity search. And that gives us like 4 or 5 top matches to our query. And then we're able to pass this directly to the large language model so that the large language model uses that to base its answers. So the answers are fundamentally grounded in the information that is passed to it. It's not using its training data um, to answer the question. It's not hallucinating. It's basing the answer on the facts and the data that are stored in our vector database, which represents our vast sources of historical knowledge. So, this approach, I'm using LangGraph, and LangGraph is amazing. It's really great in structuring the code and ensuring that the process is we are separate in the process. We're separating the reasoning, the LLM, from the retrieval process. So we turn the structure of the problem or the solution into nodes, and these nodes are agents that do different things, and they communicate back and forth in order to solve a problem. So the question that the user asks is combined into the state. The state represents a set of information represented by a human message, an AI message, which is the response to the question, the query, and a system message and a tool message. The system message represents a guardrail that basically governs the behavior of the LLM as it basically processes the information and responds. And this is kind of a contract that the LLM has to abide by in the process of responding to the queries. So the state here is this set of information, this set of messages, basically, they are passed between agents or between nodes, and they're modified in the process. Each node takes in the state, which is the combination of these messages and the history, and adds something to it, and then passes it to the next node. And that's what's enabled by the graph structure and the execution. So in that case, we have a simple two node, two major node solution. As you can see, we have a large language model agent, which is the reasoning engine, and we have a retriever agent. So the large language model agent or node responsibility is to understand whether there is a need for calling a tool. And the tool here is the second agent, the retriever agent. So if there is a need based on the query, the LLM basically goes ahead and calls the retriever. The retriever goes ahead and retrieves information from the vector database and pushes it back to the large language model node or agent. And the agent, the large language model agent in turn, is able to respond based on the information, which are the top five matches in this case that match the user query. So it brings back these documents to the LLM. The LLM makes sense of it and responds to the user. And this cycle continues based on what we call here a conditional edge. The condition here is whether there is still an interest from the user to continue the conversation or not. If the user types exit or break, basically that means that the user is signifying or signaling that he or she is interested in finishing the conversation, and we go to the end of the graph execution. So that's a very simple way to implement a RAG with a large language model and for this problem. So in that paper, I see I'm using a paper on conditional predictive maintenance for rotating machinery. And I'm able to ask questions, very deep questions, such as the thresholds and explanation of certain types of signal processing methods for extracting features and so on. And the answers are very good. They are based on the information, and and actually the large language model is able to find the sources of the information or the documents that has these information. So it's grounded. It's basically very unlikely to hallucinate, because it's, as I said, it's basically based on understanding and synthesizing information based on the documents retrieved from the historical database. So that's the way to really scale your operation. If you're looking to scale your operation, if you're having shortage in engineers, technicians, that can sort of become like a junior engineer or some type of engineer that you're asking um, to give you at least the context, the previous sources, the exact sources, to hone in on the exact parts of the document that kind of are of interest to you and so on. Um, so it's really a very important way to scale the operation, and it's a very nice way to both to leverage large language models without a basically the issues with hallucination and generic answers that are not basically based on our domain specific or organization specific knowledge. So the article is there. Please check it out. And if you have any questions, please get back to me or contact me on LinkedIn. Thank you.